Hello, I am Jonathan Gabay, junior studying digital media technology at Kansas State Polytechnic. I am currently in a hardware and networking fundamentals class, and if you're watching this video, hopefully you've been on my blog and have been reading up on some of those lab reports and weekly reflections. Starting today, I am going to replace the written blogs with video blogs. I'm hoping that it will take less time to produce rather than posting a page on my webpage every time. I'll just create a short video, keep it simple, keep down the editing, because anybody who's done video editing before knows that it can take a long time to make videos, to edit, cut them down, make sure everything's working well. So just to jump right in, I have about 5 of these I need to do. It's currently October 30th, and if I'm going to be totally honest, I am probably about 5 weeks behind on doing these weekly reflections. So we're going to start with week 5, and we're going to work our way from there up to week 10, which will be current. So let's see what we've got here. Just going to zoom in a bit. If you can see, we've got networking hardware for week 5. So here we're covering different pieces of hardware, what's covered in them. Starting from the top, CSMA CD, that is, and I understand if it's not very legible, carrier sense multiple access with collision detection. If you're on the internet, this is an important thing to you. If there are collisions with data, you're not going to get the packets you need. So CSMA CD is going to listen for other data transmissions on the network, and when it's free, it's going to start transmitting. This is going to prevent collisions, and if there is a collision, it's going to allow it to try again. Going from there, we've got protocol. That's a pretty basic thing. An agreed upon method of communication. I think that's pretty basic. You don't have to be a networking professional to kind of understand what that means. Building off of that, though, we have routing protocols. Routing protocols are exactly what they sound like. They're protocols that are, wow, that's barely on page. Let me move that. There we go. Anyway, these are going to connect different entities, as my notes say right there. It's going to allow data transmissions to be routed to the correct destination. This seems to be just a lot of software stuff for the most part, but then we have interior gateway protocols, same entity, organization, so that's going to be within an entity, computer, whatever you want to think of here. It's anything that's being transmitted within that device. Then we get into the actual networking hardware. So a few things. The most common items are, network adapters, NICs, network interface cards. Those are the devices that you used to plug into computers back when having a network capability was optional. Nowadays, the NIC is going to be installed directly on the motherboard, so if you buy a computer, you don't have to worry about installing a separate piece of hardware. We also have repeaters and hubs, bridges and switches, and routers. Let's see. Yep, okay, so that was that. So NICs I already talked about. They run on MAC addresses. I didn't touch that, but a MAC address is a physical address, so unlike an IP address, which you may be familiar with, a MAC address isn't going to be changed. It's pretty much written on the card, Network adapter, that down here, that essentially is a network interface card. The different types of networks are going to have different capabilities, so your network adapter has to be compatible with the network. Alright, Moving on from that, we'll go straight to repeaters. Repeaters are a network device that's going to just repeat a signal that it receives. Signals and networks that we use today, digital signals, they're all run through electricity, and electricity cannot stay at full strength the longer you go. So, the level of power that it has, or energy, decreases the further you try to send it. So that's when you implement something like a repeater, which is essentially going to receive the signal and then resend it to extend that signal length. Right there, extends length, yep. Then we have hubs. A hub is like a repeater, but instead of repeating a signal to one port, it is going to essentially broadcast the signal that it receives to all ports. So with a hub, a hub is going to be a device that you would connect multiple devices to, and that would facilitate communication between multiple devices. This is, as it says here, a layer 1, and layers being the OSI model, which I've covered in a previous blog post. Anyway, layer 1 is physical. There's no routing protocol. If you are using a hub, it is going to send a message to every computer that's connected, and it's not going to care if that's the intended recipient. To get around that, computers are pretty much going to see, oh, this message was meant for a different MAC address or something, and I'm just going to ignore it. So repeaters and hubs are layer 1 devices. They're very basic. They just repeat signals for the most part. Then we get into bridges and switches. So a bridge, unlike the previous set of items, a bridge is a layer 2 device. Layer 2 being the data link layer. So this is where things get a bit smarter. A bridge is essentially a more sophisticated repeater, as it says there. So there are 2 ports, one on each side. Like a repeater, it's only going to take a signal and repeat it, sort of. Having the 2 ports creates 2 collision domains. And like I said, well, I mentioned collisions earlier. Collision being where electrical signals transmitting data are going to collide. And of course, you can't have that. That's going to interrupt the data flow. It's going to mix up packets and other information, and you don't want that happening. A bridge is going to prevent that. First of all, it's going to build a table of ports and MAC addresses. So when you send a piece of data over a network and it reaches a bridge, it's going to be able to tell what the MAC address was of the device that sent the message. After it receives that, it stores that data, and it just received a message that meant to be sent, so it's going to try to find the recipient where it's supposed to go to. The thing about a bridge is the only thing the bridge has to worry about is which port those devices are on. So it doesn't know the IP address of the computer. It doesn't know where the computer is at. It just knows that the computer is in that direction. Think of it like that. You have north and south. The computer from south sends a message north, and the bridge is going to say, okay, well, this is going to go north somewhere, and it just sends it north. Going off of that, we get to a switch, which is essentially the same as a bridge, but a switch is it's essentially a multi-port bridge. So just shoving a lot of bridges together is going to give you a switch, somewhat. Just like a bridge, it's going to build a MAC table, a port MAC table. It's going to keep track of what computers on what port. The benefit of a switch over a bridge is it creates many collision domains. So you can plug things into a switch, a lot more things than a bridge, but it essentially does the same thing. It's going to build that table, it's going to determine in which direction it's going to go, but instead of just north and south, it might have north, south, east, west, northeast, southeast, southwest, northwest. However many ports are on a switch is going to be how many directions that it's going to send data. And we'll get to it later, but there are other devices that are used in determining the position that it goes, not just throwing it out in the wind in that direction. And like I just said, here we are. A router is the next level up. It is layer 3. So we've been from layer 1 to layer 2, and now we're on layer 3. So a router is going to have 2 or more interfaces. An interface being essentially, I would describe it as a sort of network. An interface is going to be the point at which a device or a set of devices is going to try to communicate with another set of devices. A router is going to belong to 2 or more networks. As a result, there's pretty much an in and an out port on simple routers. You have a port coming in from, if we're talking commercial from or residence from your home, you have a port coming in from the outside, from the internet or from your internet service provider rather, and you have a port going to the other side, which is going to be your network, your home network, which is where your computer's plugged in, your Wi-Fi hotspot, your phones connect to it, your game devices, even TVs and refrigerators now. So a router is going to facilitate the connection between the 2. So on a layer 1, you have your ISP, there's running cable to your house. Every now and then they have to have a repeater to stretch the signal even further. At some point they might hit a spot where they split off signals, part of a network, they do that. They might put a hub to split a signal off multiple directions to cover a wider range. Then when they get to your house, they have signals come in from the outside, they come in, they hit your router, and then the router is going to then direct that data to where it needs to go. And this layer, unlike the previous ones, it's not going to just send it in a direction, it's not going to guess. The router is going to send a signal to the absolute destination that it needs to be arriving at. Good thing to note here, they have protocols. You might be familiar with IP being Internet Protocol. Yeah,